Hello, welcome to naming and drawing different functional groups. The first group is alcohols. There is two methods to naming alcohols. In my grade 12 college class, we have just focused on the first method, and if you're in that class, you only have to worry about method 1. For alcohols, the group is an OH group, and our first method that we're going to use is called the hydroxy method. So wherever we see an OH group, we're going to use the word hydroxy to identify that group. So we have an example, 2-chloro-4-methyl-1-hydroxybutane. We would start by drawing the parent chain, which is always the last word of the name. So bute represents 4 carbons, the AN represents all single bonds between the carbons, and once we have that parent chain drawn, we can then draw the other groups. So this is saying on the second carbon, we have a chloro group, which represents chlorine. On the fourth carbon, we have a methyl group, 1, 2, 3, 4. So on this carbon, I have a methyl group, methyl meaning that group has 1 carbon in it. And on the first carbon, there's a hydroxy group. That is the OH group that identifies this molecule as an alcohol. The rest of these carbons can form bonds with hydrogen to fill their 4 necessary bonds, and that would be our molecule. Moving on with method 1, if we are given a diagram and we're asked to name it. The first step is to identify the longest chain and make sure that our OH group, our hydroxy, is at the lowest number. So you could start numbering from the right side or the left side. If I were to go on the left side with the pink system as being number 1, the hydroxy would be on the 7th carbon. So if I look at the right side and try the blue numbering, we still have the same amount of carbons as the longest chain is 8, but we can see the hydroxy group is on the 2nd carbon. So that hydroxy group wants to be on the lowest carbon possible, so we will start the numbering from the right, and that identifies where the other groups will also be. So once we have our longest chain, that's the parent chain, we can identify we have other branches coming off the parent chain. Because there's 2 kind of sticks coming off each of these groups here, 2 carbons or 2 sticks represents an ethyl group. Both of these would be ethyl groups, and of course our circled one is the hydroxy group. When we go to name this, the first method is using the word hydroxy. We're also going to name the ethyl groups in alphabetical order. So ethyl comes before hydroxy, so we will write our ethyl group first, then our hydroxy group. And at the end is always the name of the parent chain. Because I have 8 carbons and they're all single bonded, this chain is going to be called octane. Then we also need to show the location of where these groups are. So I have 2 ethyl groups. Whenever you have 2 of the same group, we need the prefix di and the location of each of them. Both of them are on the 5th carbon, so we would put 5, 5 to show the location of each of them. Numbers need to be separated by commas, and numbers and words need to be separated by dashes. We also have to show the location of the hydroxy. There's only 1 group, so we can show the location of it at 2, and then we can move the octane to the end, so this is all 1 word. This is how you would go from the diagram to the name using the first method of naming. We can look at the same example and name it using method 2. That is, instead of calling that OH group a hydroxy, we change the ending of the parent chain to have an OL ending instead of the ane ending that we're used to for regular alkane chains. So we have further established that we're going to name it from the right side from the previous example. So we know it goes 1 to 8 in that direction. We know we have 2 ethyl groups at carbon number 5, and we have an OH group at carbon 2. So the same thing, we're still going to do 5,5-diethyl because that hasn't changed. But with the method 2, instead of calling it a hydroxy group, we're going to use the regular alkane parent chain, which would be octane. We're going to take the E off and change the ending to OL. So this second method of naming would be called 5,5-diethyl octanol. And because we have that OL ending, that tells us we have an alcohol. However, similar to the first example, we have to show the location of that alcohol. So we're going to add the number in front of the OL, and it would be 5,5-diethyl octane 2-ol. Another way you could write that would be 5,5-diethyl 2-octanol, and that 2 would then be implied that it's referring to where the hydroxy group is, or the OH group, with the OL. So this is method number 2. Again, if you're in the college class, you only have to worry about method 1 using the name hydroxy.